Okay, we had some Zoom troubles today, and I apologize for that. And what I'm going to do is just simply repost it. So hopefully those troubles will disappear. So as I do the problem set, what I want to claim to you, certainly if something's not making sense to you, you really need to study the material that was presented to you in the lecture. And I really mean not study, and then try again and again and again. I mean, multiple times sometimes. It's only first try, second try, third try, keep trying. However, if you're at an impasse and need help, please come by and see me, and I will try to help you. All right, let's take a look at number one. And number one says, the measure of an angle is 330 degrees in center position is given. Find two positive angles and two negative angles that are coterminal. So what I'm going to write down is that, theta sub k, this is a coterminal angle, is going to be equal to 330 degrees plus, well, all I do is I rotate. And how much do I rotate? 360 degrees. And then I put a K over here. All right. So, maybe I'll make my K's more consistent. I have a tendency to do that, by the way. So I'll write that down as a cursive K. All right. And what could K be? K can be any integer at all. Any integer. So if I took theta sub 0, K0, I'd get 330 degrees. If I took theta to be 1, what would I get? 330 plus 360, which would be 690, right? Relatively simple computation. If I took theta to be 2, these are coterminal, by the way, what would I get? 360 times 2 is 720. 720 plus 330, 750. 1050 now. I'll put this over here. Now, some can say, I need a calculator to do that. I hope you don't, but you could do this all day long. I don't want to do it all day long. What I want to do is I want to go theta to minus 1. See what I get. So what are you going to get there? 330 degrees minus 360, which would be minus 30 degrees now. Let's do theta minus 2. Well, what's that going to be? 330 degrees plus 360 degrees times minus 2. Well, that's minus 720. Maybe I should write this one down. So it's going to be 330 degrees minus 720 degrees. What would that give you? Let's see. 390. I'm sorry, minus 390. Let's go back and read the question to you. It says the measured angle is 330 in center position. Find two positive angles and two negative angles are coterminal. Well, I just found a bunch. Let's write down the two positives. These are two positives that are coterminal. Again, this is a defining feature of coterminal for degrees, where that K is an integer. And I found two negatives, and they're over here. Let's look at the answer key, see if we got those. Again, we look at the answer key for a reason. We want you to look at the answer key. All right, that's number one. I'm going to go to number 2 now. Number 2 is a relatively simple question. And what does it say? What quadrant is it in? And I'm going to draw a picture, not that you have to, but I want to emphasize this in center position. I got my initial side here, and I have my terminal side at 76.7 degrees. I'm going to say, roughly speaking, something like this over here. So 76.7 degrees here. What's their question? What quadrant is in? It's in the first quadrant, or just write down the word first. Whatever you prefer. Roman numeral or the word. Relatively simple. Let's go to the next one. Number 3. Now, what does this one say? Determine the quadrant. Well, it's really the same story. And that story is, I'm going to draw my axes down, standard position, initial side. That's my initial side. Come with my terminal side down. When I do that, I want to claim to you that I'm not going to say it's perfect, but I need some idea what's going on here. It's being rotated like this. Minus 90, minus 180. Now, I got to go more. How much more do I have to go? Well, if you look at the number, I have to go 43 degrees, 43.6 degrees more. So I got to put that down for you. And this is the angle. Put this over here. And what's the angle? Minus 223.6 degrees. Not that they asked for it, but I do want to write the reference down for you. The reference is an acute angle formed with the abscissa. And what's that angle going to be? It's acute. That means it's between 0 and 90 degrees, and it's going to be 43.6 degrees. By the way, I know they didn't ask for that. I just want to review that concept with you. So what do they say? Determine the quadrant. Well, I'm looking at it. That's quadrant 2. Or you could just simply use the word second. Whatever you prefer. All right, let's go to number 4. relatively simple questions. And this one over here says rewrite minus 288 degrees as a multiple of pi. You know, pi's you have to understand it has no unit on it. So they want me to go to radian measure. I'll write that down for you. And what's the conversion factor? Pi over 180 degrees. What's nice about this? Degrees cancel off, relatively simple. What do you get? Minus 288 over 180 pi. By the way, I'm not opposed to the answer, but unfortunately, most people are opposed to that answer. What they want you to reduce it. So I can write this on the side for you. Again, if you're fast at this, please go quickly. I'm not asking you to be slow at anything. So it's going to divide by 2, 144. 2 into 180 is 90. Well, I can divide by 2 again, right? What would you get? 72 over 45. And now I'm starting to see there's a 9 there. 9 into 72 goes 8 times. 9 goes into 45 5 times. So what's it going to be? Minus 8/5 of a pi. It's right over there. All right, let's go to the next question. And number 5. And number 5, relatively simple question. I really mean that. It's basically saying, can I rewrite the 300 degrees as a multiple of pi? Well, we just did something like that, right? These are kind of warm-up questions. It's going to be pi over 180 degrees. I'm going to say degrees cancel off. And what do you get? Well, you get 300 over 180 pi. And I'm going to say that's reducible. And I'm going to look at that. You could do 2's again. Here's the deal. I'm looking at those numbers and they have something to do with 60. 60 goes into 300 5 times, and it goes into 180 3 times. So what's it? 5/3 of a pi. All right. I think we just finished that page. Let's go to page, the next page, and that'll be problem number 6 now. Take a look at number 6. And this one says, find 2 positive angles and 2 negative angles that are coterminal. And let me write this down now. This is a coterminal. I'm going to put down theta k, sub k. And now I got, 1.125 revs plus, well, I'm going to rotate 1 more around, 2 more around, 3 more around. So I'm going to say in general, we're rotating 1 rev. And then the number k over here. With the understanding that k is an integer. All right, so k is some integer. Let's write this down. Theta sub 0, well, that's easy. 1.125 rev. Theta sub 1, what's that going to be? 2.125 revs. Theta sub 2, I'm getting tired already. 3.125 revs. Let me do theta minus 1. A little more complicated. Let me write this down for you. So it's going to be 1.125 revs. If k is minus 1, I'd have minus 1 rev. What's that going to be? Well, that's pretty simple. It's 0.125 revs. Let me do theta minus 2. That's going to be 1.125 revs minus 2 revs. Again, I hope you're not really bad with arithmetic. If you are, I guess you can use a calculator. I hope you're not using a calculator now. But what's that going to give you? Let's see, 1.125 minus 2 is going to be minus 0.875 revs. Let me do theta minus 3. That's, and I guess you're doing too many, maybe. And what would that give me? Let me see. Minus 1.875 revs. Now, what they said, get 2 positives. Well, I'm going to box them. I like this one because it's really kind of like the smallest number there, closest to the origin. And I like this one here too. By the way, this one here is the original one. They said find 2 more. I just did that. And let's go for the 2 negative ones. This is negative. We'll look at the answer key later. And this is a nice negative one over here. Let's go to the answer key. Let me see if I've gotten them. Did I get the 0.125 revs? Yeah, right there. Did I get to 2.125 revs? I got that one right over there. Did I get the minus 0.875 revs? I did. Did I get this one over here? I did. So it says, why did they choose those when there's an infinity to choose from They like to stay close to the origin. All right, let me go to problem number 7. And it says, find, if possible, the complement to supplement. And I want to put a complement has to be an acute angle. All right. And what's complement going to be? I'll write this down for you. The complement, I'll just say C for complement, is going to be 90 degrees minus 37 degrees. And what's that going to give you? That's going to give you 53 degrees. Let me just check and see if that's true. 53 and 37. Let's see. No, 90 looks good. So that's a complement. What's a supplement? Well, it's going to be 180 degrees minus 37 degrees. If you don't know these definitions, by the way, you would want to go back and study the notes, what we presented in class to you. It's so important to do that, which is going to be 143 degrees. So I found the complement. The complement is 53 degrees. I want to point out that's written down for you. And I found the supplement, and the supplement, they say, is 143 degrees. We're in agreement, and that's good news. We want to be in agreement. All right, let me go to number 8. Number 8, they want me to do some computation. They say use your calculator, but show work. I'm going to write down what the work is. All right. So it's 102 degrees plus, I need to convert 15 minutes into degrees. And what's that conversion factor going to be? Well, there's going to be 60 minutes in every 1 degree. We'll do the work later. I'm just writing down what the work is. Plus 33 seconds, and I want to go to degrees. So every 1 degree, and you'd have to know this, was presented in notes during lectures, 3,600 seconds. All right. Now what's canceling off here? Again, when I'm going to point this out there, I'm hoping you understand what's canceling. This cancels, that unit, and this cancels. And what am I left off with? A computation. And someone's going to wonder what that computation is. Well, it's really not that bad. Everything's in degrees now. And I'll write it down for you. And it's going to be 102 degrees. Whoops, sorry about that. It's going to be 100. I did it again. 102 degrees. And what's next going to be? Again, if you need to use a calculator, use a calculator because it says use your calculator. But what's this going to be? It's certainly going to be degrees. And what's 15 divided by 60? Wow, that's a quarter, 0.25. I got to be honest, the last one's kind of a killer. So what I want to recommend is, you can use Sage if you want. I don't mind. You can use your calculators, and your calculator may be your cell phone, right? It's possible. You might say, oh, my cell phone's my calculator. The problem for some students is that even though they have a calculator, they may not know how to use it. And if you don't know how to use a calculator, I'm going to say, please come by during office hours, and we'll be more than happy to go through it with you. I mean, more than happy. So I'm going to say, if I did this on a calculator, I would get this number over here. 00916. Oh my God, it goes on like forever. Now, someone could you have done that by hand? I could have, but I don't want to do that by hand. Certainly, the other ones I can do. I want to add them together now. And what would I get? I want to point out, they use a key word here, to the nearest 1,000. All right, let me write this down now. And I'm going to write down, approximating now, 102 point, and again, you're allowed to use calculators for this because it says so. Look at the answer. Who knows? Maybe I made a mistake. Good job. All right, I got that. We got a number 9. Ooh, number 9 is interesting. And what they have down here is they've got the degree minute seconds. And I want to point out where that is. Give me 1 second. Some calculators have this built in, and they can take a decimal degree with a switch of a button. It'll write down degree minute seconds. But what I'd like to do is, I would like to show you what the work is going to be. All right. And that's what's important to me. What's the work? I'm not really interested in the answer, but it's going to be, let's see, minus 17.8567 degrees is equal to minus 17 degrees. I got a fraction now. And what's fraction going to be? 0.8567 0.67 degrees. And what I want to do is convert that to minutes. And how would I do that? There are 60 minutes in every 1 degree. What cancels off here, though? And I hope you know what cancels off here. The degree symbol cancels off. So I'm left off with the minutes. And I want to go through the computation, and I'm going to do it on a calculator. What I'm going to do, 60 star 0.8567. And what do you get? I'll write it down for you. You get, whoops, I'm sorry. You get 51.402 minutes. I'm going to write that down now. What's that going to be? 51 minutes. Now what I'm going to do, I'm going to take the minutes, which is the leftover minutes, by the way, the fractional part, 402, and I'm going to go to seconds. And let me repeat this for you. There are 60 seconds in every 1 minute. What cancels off here? This. And let's write that down for you now. I'm going to multiply it, and I'm going to take 60. And I'm using a calculator, by the way. I'm doing what they told me to do. And what do you get over here? I'm just going to write down what I'm seeing in my calculator. I get 24.12. All right. I could write that down. And I could say I'm done. But I really didn't read. And I want to go back and read it to you. They want me to report it in whole number. Everything in whole numbers. So I got to approximate this thing over here. So what I'm going to do is I'm going to approximate this now using whole numbers. Whoops. Minus 17 degrees, 51 minutes, and rounding it up to a whole number, it will be 24 seconds. Look at the answer. I feel good about that. Let's go to the next question, and that'll be number 10, right over here. All right. Again, as I read these things to you, say, so you give me too much detail. I don't know why you talk so much about these problems over here. We're trying to teach you. We want you to move forward. We really want you to move forward. That's a key characteristic of everything that we do at Essex County College. We want you to move forward. So I'm going to read it to you. It says, in a circle with a 120 centimeter radius and an arc of 132. So I want to kind of draw a picture of what that looks like to me. And I know there's a big circle over here, right? And I know the circle has a radius of 120 centimeters. I know that. It told me that. And then they said an arc of 132. Well, if that's 120, an arc of 132 would look sort of like this over here. I'm not very good artist, am I? So this is going to be the arc, and the arc is 132 centimeters. Now, if you remember in the lecture, we gave these things letter. Arc length was S, and radius was R. And this is still 120 centimeters over here. That's still R. What's their question? What's the angle? I don't know. If I were looking at that, though, and I'd ballpark it, I'd say it's somewhere around 60 degrees looking at it. I don't think they want me to ballpark these things. They want me to put the right answer down. And I'm going to put, it's a defining feature of the radian measure. And what's that going to be? S over R is equal to theta. That's a defining feature of the radian measure. What's S? 132 centimeter. What's R? 120 centimeter. So that's what theta is. What's nice about this, though? Centimeters cancels off. And what am I left off with? I'll write this down for you. Theta is 132 over 120. Well, you know what? I'm not opposed to the number, but most people are. They reduce it. And let's go through it. I'm looking at it. I'm going to divide by 2. I get 66 over 60. Oh, I can divide that by 6, right? That'll be 11 over 10. I could also write that as 1.1. They're both all equal. All right. Now, somebody says, which number do you like best? It doesn't really matter to me, but this is a good answer, and that's a good answer. Now, what's their other question? All right. I found the radian measure. They said, how many degrees? Let me write this down. Theta, 11 tenths. There's no unit on that. And I want to convert to degree measure. What's that going to be? 180 degrees over pi. All right. Not that I want to spend a lot of time in that, but I'm going to say that's 11 times 18 degrees. Someone says, what'd you do? I divide through by 10 over pi. Let's see, that's going to be 11 times 18, that's 180 and 18, 198 degrees over pi. And that still looks pretty crazy to me. I want to approximate it. So I'm going to take my little computer. I'm going to type in the number 198 and divide by pi. And I'm just using my little computer. And I mean, a really four-function calculator is what I'm using. And what do I get? I get an approximate number. And that approximate number is going to be 63. That's what that squiggly thing means over there. And I'm 0.25. I'll put this over here. That's an approximate. I want you to look at the answer key. And again, the reason for that, we want to see if we get them right. And I'm seeing this. All right. I'm also seeing the 198 over pi. I'm seeing that over there. And I'm seeing the approximate answer 63.025. I feel good about that. And I want to certainly move forward. And again, our desire is for you to move forward. Let's go to number 11 now. All right. So number 11, it says find the radius r of a circle whose arc length is, oh, wow, look at that. 3 meters and an angle of 60. I think I can do that. Let's put this down a picture. So let me see if I get the 60 degrees down first. About 60, right? And the arc length is 3 meters. Well, I'll be honest with you, if I were looking at that and someone said, what's the radius? I'd say, you know what? The arc length and the radius look about the same to me. So if I were ballparking this, I would say the radius looks 3 meters. All right, I would say that. Now, what do I have to do? I have to use that formula that I know. What's the formula going to be? Well, the defining feature of radian is S over R equals theta. And this is the defining feature of the radian measure. Unfortunately, they didn't give me radian, they gave me degrees. Let's write this over here. 60 degrees. I want to get radian down. That's pi over 180 degrees, right? Which can be pi over 3. So what do I got over here? S is 3 meters. R, I have no idea what that is yet. I think it's around 3, by the way, is equal to pi over 3. By the way, the other formula that we wrote down is S equals R theta. You can also use that. It's really the same thing as S over R equals theta. I got to solve for R. What would you get? Well, you get 9 meters. Very simple algebra, by the way, multiplying both sides by 3 and multiplying both sides by R and dividing both sides by pi. I'm going to approximate that, and I'm going to use my calculator. So I'm going to take the number 9, and I'm going to divide it by the number pi. And what are you going to get? You're going to get 2.8. They want 2 decimal places, by the way, 86. All right. Let's see if we got that answer. I'm seeing the answer over here. Okay, let's go to number 12. And number 12 says, find an angle between 0 and 360. Let me write this down for you. They want me to find an angle between 0 and 360 degrees. All right, now, how many angles are between 0 and 360 degrees? There's an infinite number of them. They want me to find one that meets a condition, and they say it's coterminal with 2,595 degrees. And I hate to say that's a large amount of rotations. All right. So what I'm going to do over here is I'm going to say that the angle, I'll write this over here, 2,595 degrees is equal to some angle theta that's between 0 and 360 degrees plus some multiple of k, with the understanding that k is an integer value. All right. Now, someone said it's too much work. I don't think I could go through all that work to get there. But I got to say that, if you took 360 and you multiplied it by, let's say 7, you would get 2,520. So I'm going to take k equals to 7. And I got a feel for numbers. So, and I think you do too. Probably better than I do. You're younger. Your brains are spongier. And that's a 5. Sorry about that. So let's see, 7 times 360 is going to be 2,520. All right. And I'm going to subtract that number from both sides. Again, this is not the only way to do the problem. And what would that give you? Theta is, let's say, 75 degrees. I found my theta. What's my theta? 75 degrees. Let's look at the answer key, and I'm seeing it. It's coterminal. All right, it's coterminal. Let me go to number, oh boy, 13, right? Whoops, sorry about that. Okay, clocks cause problems for students. A lot of times students, their idea of a clock is their cell phone. Historically, a clock is that thing you hang on a wall with little hands on it, and they're talking about the minute hands. So I'm going to draw my little picture. And I certainly know about time, and I know about the hands on the clock. So the first thing it says, through how many radians does the minute hand on the clock rotate? You know, I don't like talking radians about it. I like talking my first language is degrees, but I want to get an idea where 1240 would be for the minute hand. And I think you probably know the minute hand would be over here at 1240. And then, like I always say, the wheels on the bus go round and round. The hands on the clock go round and round. And what's the next time going to be? Well, this minute hand keeps flipping around, right? And eventually it's going to land over here, which would be 1:30. All right. So this is going to be 1:30 p.m. And this is where the minute hand was at 12:40. Oh, you know what? Oh, yeah, p.m. I'm sorry, p.m. I'm glad I read that, by the way, because it was a.m. I'd have a lot of rotations to go through, right? A.m. to p.m. This is 12:40 p.m. to 1:30 p.m. Yeah, I hope you got an idea how many minutes have transpired, all right? So if you look at that, you know, there's, let's see, 15, 10, 25. You get the idea what I'm doing, right? 30 and 25. You can do the minutes. They didn't ask for that. They asked for degrees. So let's talk about it one step at a time. I hope you realize it is rotating like this. I'm going to talk about degrees, by the way. So I'm going to say, as I'm doing this thing over here, my main concern is I know, you know, each of the quadrants is 90 degrees. This is a 90 degrees rotation. That's 90, and this is 90. My concern about this over here, what's this angle here? Well, if you thought about 1240, 5 minutes more to go to get to that abscissa. And if you thought about 5 minutes, it would be 1/3 of the 90, which would be 30 degrees. So what I get there is an angle. If you looked at it and add all those numbers together, you get 270 and 30, which would be 300 degrees. Now, someone says, why are you thinking in degrees? It's my first language. Of course I'm thinking in degrees, but I have to get into that radian mode because they said they wanted radians. How do I do that? A conversion. And let me write that down for you. Pi over 180 degrees. What's nice about this thing over here? I have a cancellation. The degrees are canceling off. And what am I left off with? A fairly simple computation. It's 30 over 180 pi. I'm going to divide through by 60 because it's easy. You can get 5/3 of a pi. All right, relatively simple. But again, you may have to review, you know, basic picture drawing and understanding about the time. Let's do 14. 14 is a little more complicated. I want to point out we use numbers that are relatively simple to do. However, you may not be in agreement with simplicity. Like if I said 5 times 5 and you said that's just advanced mathematics, we're not in agreement. I actually think these numbers are simple. All right. So the first thing I'm seeing is I'm seeing what's called a linear speed. A car is traveling, and the linear speed is 60 miles per, that's miles, by the way, hour. All right. So someone says, well, what is that linear speed? I think when we talked in the notes, we had problems that we expressed linear speed, and we called linear speed the velocity of the problem. And let me remind you what we talked about in the notes. We talked about S equals R theta in the notes. I divided both sides by T, and S divided by T we called velocity, and theta divided by T we called angular speed. So velocity, linear velocity, is equal to the radius times the angular speed, which is the letter omega. All right, so let's keep going. This is V, and I want to keep reading it to you. It says a tire is 24 inches in diameter, which means the radius of the tire is 12 inches. You know, I immediately see problems now. I see they're talking about miles and hours, and now they got inches. Right? We'll talk about that later. It says find the angle. Well, I'm not going to read beyond that. I want to find that angle, but the bottom line is this might be a tough question to understand it. So I really have to say, if it is so difficult to understand it, I got to start writing things down. And what am I going to write down? I'll write this down for you. V equals R omega. Well, I know V and I know R, but they're not in the same unit. And this is where this footnote comes into play. So I want to go through this with you. If you look at the footnote, they say something that you may not be aware of, particularly if you did not grow up in the United States. Now, I grew up in the United States. I'm kind of in tune to this. I don't like the system, by the way, but I'm in tune to it. I'm going to write this over here. This is V. I'm going to convert this to inches and seconds. Now, in the footnote, they tell you every 1 mile has 5,280 feet. They tell you in the footnote that every foot has 12 inches. All right, I'll push this over here. Don't worry about the question. We'll get there later. If you're not worried about that, you should stop worrying about that. You should worry about written down over here. All right, let's see what we got over there. So miles would disappear, feet would disappear to inches. And I know they talk about seconds. So I'm going to say that every 1 hour has 3,600 seconds in it. Now, by the way, I think that's common knowledge. I don't think that miles to feet to inches is. But I'm going to go over here and start canceling things out. And certainly hours cancel. Miles would cancel. Feet would cancel. And what would you left off with? Inches over second. So I'm going to write this over here. We'll do some arithmetic. I don't need a calculator to do this. However, you may need a calculator. So 60, 5280, 12. And what do you get in bottom? 3,600. And what's the unit in this thing? Inches per second. All right, let me see if I can do that. Oh, geez. Let's see, 60 goes into 60 once, right? And it goes into 3,600 60 times. That's not so bad. I think I could do that. I think most people can do that. I hope you don't need a calculator. Let's see, 12 goes into 12 once, and it goes into 60 5 times. And again, I think you can do that. I got to do some work here now, don't I? So I got to divide through by 5. I have a little grade school arithmetic on the side. I'm going to do 5 into 5280. That goes in once. Let's see, 2, that would be 0. That's crazy, isn't it? 28. 528, 5 times. 5 times 5, 25. Whoops. 306. Hope I didn't make a mistake anywhere. We'll know if we did make a mistake, by the way. Okay. Inches per second. All right, let's write our formula down. So V equals, what does V equal? R. What's R? G, it's 12 inches. And what's omega? I have no idea. Geez, I got some work to do, don't I? I would divide both sides by inches, and I would divide both sides by 12. Well, a lot of work here, isn't it? So I'm going to write this on the side for you. It's a lot of work for me, too. 1056 divided by 12. Let's see, I'm going to divide by 2. That'll be 528. And that would be 6. And I'm going to divide by 2 again. That'd be 250, 264. Divide by 3. And I got to be honest with you, I'm looking at 3 into 264. And I think it can be done. I'll tell you why, because 264, the sum of the digits is divisible by 3. So this is definitely going in. I'll write this on the side. 3 goes into 264. Let's see, 8, that'll be 24. That'd be 20. Oh, 88 times. Look at that. So what do we get over there? And I'm going to write this down over here. So 88 seconds is on the bottom is what omega is equal to. All right. I'm going to erase something over here because I didn't divide that other side by 12. And I don't want to do that at this point. I'm going to erase this over here. All right. Again, we're using the formula. I'm going to point out what formula we're using. We're using this formula over here. So what I did was I put down V equals R omega. So I know what omega is. Now someone says, did they ask for that? No. What did they ask for? What's the angle that would go through in 10 seconds? Well, I can do that. So it's going to be omega times 10 seconds. And let's see what happens over there. What do you get? 88 over seconds times 10 seconds. What cancels here? Seconds cancel. And what do you get? Something pretty simple. You get 880. And I'll write that down for you now. So it's going to be 880. By the way, no unit on that. What does it mean? 880. Well, we're talking about radians, a unitless number. That's right over here. Now, granted, I realize some students say, why do you put the degrees down there? Because you can. That's why. So I want to write that down for you. 880 times pi over, I'm sorry, I made a mistake. I'm not thinking. 180 degrees over pi. That's a unit conversion factor. Let me just do it in my calculator. 880 times 180. I'm actually using my calculator. I'm getting tired. And I'll be honest with you, dividing by pi anyway is kind of a nightmare. And what do you get over there? I'll write this down for you. I'll put this over here. That's approximately 50,420. Approximately. Again, if you look at the answer key, we have these answers written down for you. And for good reason. We want you to look at the answer key. It's right over here. By the way, I also put code down there for you for those students interested in looking at the code. I realize that can be overwhelming for some students. Let me go to the last problem. And again, reading through these things over here, someone say, I really can't do it. I just can't read through that. So what they give me over here, they say, find the distance between two cities whose latitudes are, and some people say, I'm not saying that this is general knowledge, but you should have some knowledge that our globe, our Earth, is kind of divided into a navigational system where we have an equator, and we go north of the equator, and we can go south of the equator. And these are what are called, latitudes. So, I would draw a picture, my lousy picture of the Earth over here. It looks sort of like this over here. That's a crazy looking Earth, isn't it? And I'm going to say that this thing over here is the equator. That's the equator of the Earth right there. Now, if you go north, this would be north, and this would be south. And what they say is these cities are in the same longitude. Now, what does that mean? The cities are directly north-south of each other. So they're along a great circle, right? They're along a great circle that runs north-south. All right, I'll keep reading it to you. But the first thing they tell me is the first one is 2517 north. So I'm going to put this in over here. All right. So, what's this angle over here? 25 degrees, 17 minutes north. And the other guy is 38. I'll put this one down in green. The other guy is 38 degrees, 51 south. Now, if you add those two numbers together, I'll put this on the side. I want to get the angle between them. So I'll put this on the side, 25, 17, and 38, 51. If you add those together, what do you get? You get 8, 68, and let's see, 50, 63, right? This is a really inappropriate way to write the number down. I'll tell you the number one reason why. We do not like to write 68 minutes down, and it's really inappropriate to do that. So I'm going to say I'll borrow 60. That would be 1 degree. So it'd be 64 degrees, 8 minutes. That's the angle theta. What do they want to know? They want to know the distance between the cities. And what's that going to be? Well, let's write this down. And I'm going to erase my S over there because the S stands, I'll write the word down, south. And this is north. By the way, although this is east, it's the equator. Okay. All right. S, which is the arc length between those two cities. Do I know the radius of the Earth? Well, if you read it, it's 4,000 miles. By the way, we're assuming the Earth is a globe, a sphere. Here comes the problem for a lot of students, and it's a problem. We cannot use degrees. We must be in radian measure. So I'll write it down for you. And I'm going to write the degree measure down for you. It's 64 plus 8 divided by 60. Yes, I'm converting. Degrees times pi over 180 degrees. What happens over here? I want to point out to you what happens over here. There's a cancellation in degrees. What's the unit you left off in the end? I'll write this down what a computer would look like. This is going to be S, whoops, sorry about that. S is equal to 4,064 plus 8 divided by 60 times pi divided by 180, and this would be in miles. I'm going to go to my computer and I'm going to do it. All right, I'm actually going to type the numbers in. Sorry about that. And that's 8 divided by 60 plus 64 times 4,000. Again, if you don't want to use a computer or a calculator, I really think it's probably in your interest to get help. All right. Let's see, pi, and then divide by 180. All right. My calculator is a really crazy looking number, and it's like all over the place. So I'm getting 4,477.35130. And I got to be honest, it keeps going on and on. But here's the deal. You know, this level of accuracy is just outrageous to write that like point something. Like if someone says, how far do you live from Essex College? You say, oh, I live 7.649992234. They think you're crazy. So I'm going to just round it off to the nearest integer. And what's that going to be? I'm going to say it's approximately 4,477 miles. And yes, I use a computer to do that. Look at the answer key, and you should be staring at those answers. Again, I put some Sage code down there for the students interested in looking at that, and we would encourage you to look at that as well. Thank you so much. If you need additional support, please consider coming by during office hours.